When it comes to setting up your animation, there's a few trade-offs that you can make. And the first one is, what frame rate do you pick? So here's an example. You've got a moving object animated at 15, 30 and 60 frames per second. And you can see the differences in smoothness. So 15 frames per second is not enough. This object is stuttered as it moves. 30 is fine, and 60 is even smoother. In general, you can say that if you want to have smooth playback, use at least 20 frames per second, although other values are pretty common as well. And depending on the target medium that you're going to use, you might need to use a specific frame rate. For example, if you want to create a DVD with a rendered animation, then you will need either 25 or 29.97 frames per second, because the specification for DVD limits the frame rates to those values. Another trade-off to make is, what is the length of your animation in the number of frames. And of course this has a relation with the frame rate, because the duration of your animation is the number of frames that you have divided by the frame rate. But in general, you can say that more frames in your animation will take longer time to render, and it will result in a larger video file. And sometimes you cannot choose the number of frames, or at least you're limited in the number of frames. For example, if you have a simulation that you ran, and it produced only 100 simulation snapshots of the data, then those are the frames basically that you need to work with, unless you want to interpolate the data between those snapshots that you have. So one reason to think about these trade-offs is that animation rendering can be quite time consuming. So as an example, a 10-second animation that plays back at 30 frames per second is only 300 frames. But if your render time per frame is 1 minute, it will take you 5 hours to render this animation in total. So a render time of 1 minute per frame might sound like it's a lot, but it's actually quite easy to get those kinds of render times. And that's due to the way that the rendering technique scales within cycles based on the amount of pixels that you have and the quality settings that you're using. So for example, if you double the width and the height of your rendered image, you increase the render time by a factor of 4, because it scales linear in the number of pixels. And if you need to use a high number of samples per pixel, for example, to get a better quality than this one, or this, then again it scales linearly in the number of samples per pixel. However, if you double the number of samples per pixel, the noise level does not go down by half, it goes down by less than that. So the rule of thumb is that if you want to halve the noise in your image, you need to quadruple the number of samples per pixel. Another reason for high render times is that you have a dataset that you need to load for each frame. That just takes time to read it in for disk. And of course, not every render is correct right away, so you might need to re-render an animation, or your disk might run out of disk space, etc. So all in all, it's going to take a lot more time usually than you think it will. So some strategies to handle long render times, especially during animation rendering. The first one is simple: use GPU rendering if you can instead of CPU rendering. And we have detailed instruction within the Blender Basics chapter of the course notes online, so you can check the settings that you would need to use there in order to set this to GPU compute. If you can use a lower number of samples per pixel. That will introduce more noise into your image, as you have seen previously. You can then enable the denoiser to see if that gives you enough quality back. And this can be a good strategy to get lower render times. Another way, especially for test renders, is if you render them in a lower resolution. There's a percentage slider within the resolution settings that you can easily adjust. It will just keep these values, the original frame width and height, the same, but you can easily render them, say, in half the resolution in both width and height. And you can also decrease the number of samples over here to speed up your test renders. And finally, if you have access to multiple machines, you can try to render your animation in parallel over multiple machines by, for example, creating job scripts to each render one part of the animation. So you get a speed up of n, where n is the number of machines that you're using. But the important part is to think about these kind of trade-offs that we've shown and what it means for your animation, how long it's going to take to render, and what quality you're going to use before you create the animation, but also during, because you're going to probably find out when you're working on the animation that things are working slightly different than you thought, that the quality might be lower or higher than you expected, etc. So it's a really an iterative process, and it's best to just adjust more than once. You can find the animation settings on the Output Properties tab, which is this little printer icon over here. And this contains the setting for the frame rate for the animation, as well as the length of the animation in frames. So you define a start frame number and an end frame number, and this together defines the length. The step size for the animation is usually 1, but you can increase this to a higher value if you want to skip frames within the animation, for example, for a test render. And these values together will define the length of your animation in seconds, as we saw earlier. So there's two methods to output an animation from Blender, and the first one is to directly write it to a video file. So Blender has the so-called FFmpeg library built in, which also comes as a tool on many Linux distributions for encoding video. And to use this setting is to set the file format setting to FFmpeg video, and then you need to define the encoding part and the video part below that. The encoding part contains the container, so this is the file format that your video would be stored in, and that can be, for example, Matroska, MPEG-4, AVI, etc. And under the video part, you specify the video codec and its settings. So often used codecs are H.264, WebM, Theora, etc. And this is a very easy way to generate a video file from Blender. You basically just set the file name over here and then pick the settings down there, render the file, and you get a single compressed video file as output. If you want to use that file for further video editing, for example in a video editor, then this can cause a little bit of quality loss, because the file that is already compressed, when you render it to this video file, will then get recompressed when you export it from the video editor, but that might not be a big problem. The other option is to output one image file per frame, and to do this you set the file format to a specific image file format, for example PNG, also called PNG, or TIFF, or OpenEXR. We recommend not to use the Windows bitmap format because that's uncompressed, nor use JPEG because that is compressed, and its compression will already cause artifacts and loss of quality within the saved images. So one of the upsides of saving individual images per frame is that you can easily inspect each of the frames to see if they're what you want. You can edit them, even in a normal editing program like the GIMP, and no quality is lost when saving the file compared to writing a video file directly. The big downside is that it takes up a lot more disk space than saving to a video file, and it can easily be 10 to 100 times more disk space compared to the video file format that we saw earlier. So the file name that you set for the output will be used as a pattern, because each frame will need to be saved to a unique file name that is based on the frame number. And by default, Blender uses a 4-digit frame number within the file name. If you want to have a bit more control over that, you can use the hash character. So for example, with 3 hashes, you will get a 3-digit frame number within the file name. One nice thing that you can use within file names within Blender is if you use a double slash. That means that the rest of the path that follows is relative to the current location of the Blender file that is open. So this means that frame.png is saved in the same directory as the current Blender file. And then after rendering an animation to individual image files, you of course want to still put them together into a video file. And here is an example FFmpeg command line that you could use for that. So this is used as H.264 as the codec. You can specify the quality with the CRF value over here. You need to set the number of frames per second for the animation, because of course you cannot deduce that just from a set of image files. And the rest of the settings is explained below, but basically this means that this file will be able to be played back on many devices, including in web browsers, due to the settings being used here. But there are a lot more settings for FFmpeg, and if you really want to know what all these settings do, then please look at the manual for it. And then there's one important topic left, is how do you render an animation from Blender. So there's two ways. First is to go to the render menu and pick render animation, and the other is to use the Ctrl F12 shortcut key. As an animation, rendering can take quite a bit of time. Luckily you can still cancel it by using escape, although it might take a bit of time before it actually stops, because it might need to finish, for example, the current frame that it's working on. So this is for rendering from the user interface, while the other method is to render from the command line. And when you run blender -h in a terminal window, you will get a long list of options and operations that you can use to control what Blender does when you call it like this. So for example, you can start Blender in the background, not showing the GUI at all. You can render a single frame, you can set the output file name, etc. There's a lot of options. So the command line options for Blender basically form a mini programming language. Certain options will perform an operation, and other options will set a value. For example, -o and then a file name is the same as setting the output file name from within the user interface, while -f followed by 1 is the same as rendering frame 1 from the user interface. So in this way you can control what you want with your command line call of Blender. For example, to render a set of frames to a specific file format, or even to load in a file and then run a Python script on that file. So a final remark is that it's easy to make mistakes with this. So for example, the first command line is fine. It starts Blender in the background, loads in a blend file, sets the output file name, and then renders frame 1 to this specific file. But if we accidentally switch these last two arguments, then we're in trouble, because even though the file is still loaded, it will then directly render frame 1 and only after that set the output file name that we wanted. So it pays to be a bit more careful with how these options are set and to see if they are correct or not.